Okay, so I'm going to start notes on the last lesson of the unit, which is solving for x with expressions. Now, this one's different because it's going to use the same rules as solving for x, but the goal is very, very different. So before we were trying to solve for a number that made our equations true so that the left side equaled the right side. That's not what we're trying to do this time. This time we're just rewriting an equation so that it looks different, and we're just going to move pieces around so different things are isolated. For example, in this first one, you see, and I'm using symbols because it doesn't really matter, numbers, letters, it matters not. It's just that the rules are the same. So right now, the one that's isolated and all alone is the and symbol, and it's asking you to solve for the number symbol. So they're saying we just want a different one alone. So we want it to be the exact same equation, just to look different where there's a different thing that's all alone. So you can be asked to solve for any letter. It doesn't have to just be x. And your answer is not going to look like a number. It's going to look like an equation, just written differently. But we're going to follow the exact same rules that we follow when we solve for x. So in this case, we have the and symbol equaling, that's my wall, so right now the and's all alone, and it's equaling the exclamation mark being multiplied to the number symbol minus the at symbol. So to solve for the number symbol to get it alone, you use the same rules. You get rid of the thing that's being added or subtracted to it first. So there's the minus at. To undo subtraction, we add. So we're going to add the at sign to both sides. Well, we still have to use the combine like term rules. And this is an and sign, and that's an at sign. They're not the same term. We cannot put them together. They're different things. So we just rewrite them as and plus at. They're getting added together, but we cannot put them together because they're different things. And it's going to equal the exclamation mark times the number sign still. But then minus at plus at goes away, cancels, eliminates, it's 0. We don't have to write it. Now the number sign is almost alone. It's almost isolated. However, it's still being times to exclamation mark. Well, to undo multiplication, we divide it away, but we have to do that on both sides. However, it's important you have to divide both these terms by exclamation mark. So we have the and sign divided by the exclamation mark plus the at sign also being divided by the exclamation mark. Because when you divide something away, it has to happen to every single term. And these two things are different terms because they're being separated by a plus sign. So you have to divide them both by exclamation. And then on the right, exclamation divided by itself is just one number sign. And now I've isolated the number sign. It's all alone. So the number sign equals that. And that's my answer. I just moved stuff around so that a different thing was all alone, all isolated. So it's the same rules as solving for x, but it has a different goal, because all we're doing is just moving stuff around so that it looks different, and that there's something different that's alone. So in example 2, right now the number term's all alone, and they say, no, I want y to be all alone. Solve for y. So I'm going to draw my line, and I'm going to get rid of the thing that's not my y. Well, the negative 2 is a part of my y. It's being multiplied to it. The thing not with the y, but that's still there on the left, is this 4x. It's a positive 4x, so to get rid of it, I'm going to minus my 4x's. Minus my 4x's. So 4x minus 4x is 0. Minus 2y's. Negative 2y's is still there. Equals. These 10 are numbers. They're just numbers. There's no letters. These minus 4 are x's. They are not like terms. I cannot put them together. I just have to write them as 10 minus the 4 x's. So I just move that term over. That's it. I cannot put them together at all. I cannot combine these because they're not like terms. Now, with y, it's not completely isolated yet. It still has negative 2 in front of it, meaning it's being multiplied to it. And to undo multiplication, I have to divide it away on both sides so that I keep them equal. So negative 2 divided by negative 2 becomes a positive 1. Y. I don't have to write the 1. Equals. Remember, I have to divide each term by that negative 2. So 10 divided by negative 2, a positive divided by a negative is a negative, and 10 divided by 2 is 5. And then negative 4 divided by negative 2, a negative divided by a negative becomes a positive, and 4 divided by 2 is 2, and they're x terms. The x can't go away. It's still there. And that is what y equals. So that's the same equation as this one. They're the exact same equation. They just look different. Things got moved around so that y's alone instead of the number term being alone. Example 3 is the exact same equation, but this time they want us to isolate x, to make x the one to be alone. So we draw our line, and 4x is the x term, so we get rid of the other one, and it's a minus 2y. So to undo subtraction, I have to add my 2y over to both sides to keep them equal. So 4x gets brought down, minus 2y plus 2y is 0, so they eliminate, I don't have to write them. Equals, I cannot add my 10 and my 2y's because they're different terms, so I just write 10 plus 2y. Okay? And now, to isolate my x, it's still being multiplied by 4, so to undo multiplication, I divide it away on both sides to all terms. So I'm left, I'm going to write over here, with x equaling, because 4 divided by 4 is 1, x equals 10 divided by 4. You cannot do 10 divided by 4. So you could just write it as a fraction, plus 2 divided by 4. You cannot do 2 divided by 4 and get a whole number, so you just write 2 divided by 4 as a fraction, and they're y's. And that's a good answer. It's okay to leave them as fractions. Actually, often I'll tell you to leave them as fractions, because fractions are better than decimals, because decimals aren't completely accurate unless you write all the little decimals, and sometimes there's a bunch of them, like 100. And so you're not going to write them all. And so usually a fraction is better than a decimal. However, you could always, or you could type it into the calculator, 10 divided by 4, and you'd get 2.5. If you want to use the decimal. And then plus, if you do 2 divided by 4 in the calculator, you'd find out that was half, 0.5 y's. So it doesn't matter if you write it in fraction form or in decimal form if you can't divide. What mostly matters is that you remember to divide both the terms by the 4. And these are both the exact same equations as this, or as this, or as this. It just is different depending on which letter we isolated and got all alone by itself.